out of 50 terms, the 11th term from right to left will be the 40th term from the left to right. To find the nth term of an AP, if the first term is A and common difference is D, the formula is AN is equal to A plus N minus 1D. We discussed some applications. Today we will see some more questions from this topic, the nth term of an arithmetic progression.
Find the 11th term from the last term of the AP, 10, 20, 30, etc. 500.
One arithmetic progression is given like this. 10 is the first term, then 20, then 30. Very simple, okay, etc. And the sequence terminates here at a 500. Our question is, find the 11th term from the last towards the first. We are counting back. We are counting towards the first number. So which term will come in the 11th position? Can you try in your mind what will be in the 11th position when we count from the last to first number?
390.
390, is he right?
Yes.
But actually he was wrong. Not only he, most of us may think like so. When we count back, we should be very careful. Most of us may make a similar mistake when we count from last number to first in any sequence, in any list of numbers. For an example, suppose someone asks which is the fifth number when we count from 10 to 1, we may say that 5 is the answer. But actually when you count with fingers, you will see that 10, 9, 8, 7, 6 is the answer. 6 is the fifth number when we count from 10 to 1. So similar mistake we may make in this progression also. Okay, so when we count from the last to first, we should be very careful. Okay, so here this is a very simple arithmetic progression because the common difference is 10 and these are the multiples of 10. The terms are the multiples of 10. We know that here in this progression 500 is the 50th term. So there are only 50 terms. So out of 50 terms, when we count from the right to left, 11th term will be the 40th term from the left to right. Okay, so our answer will be the 40th term in this arithmetic progression, and that is 400, right? So the 390 is wrong. So we made similar mistake as I said in the example. When we count from 10 to 1, the fifth term is not 5, that is 6. Okay, so in this case, when we count from 500 to 10, the 11th term is not the 39th term, but the 40th term. Here the 40th term is 400 because these are multiples of 10, so we can simply say the 40th term will be 400. So if you get some other arithmetic progressions of some other common difference may be negative or some may be some large numbers. So we should know how to do this answer by step. So I shall explain how to do this. So you listen. So here in this particular sequence, here the 11th term from the last to first will be the 40th term from the first to last. Okay, so our required term will be A40. A40 will be the 11th term from last to first, and it will be the 40th term from the first to last. So our question now reduced to find the A40 of this arithmetic progression. So how can we find the A40? So we have A is equal to 10. Now we have common difference is also 10. So to find A40, we have the formula An is equal to A plus N minus 1D. Okay, so apply the formula, you will get A40 is equal to A is 10, so 10 plus N minus 1, N is 40, so 40 minus 1 into D. Okay, D is again 10. Okay, the next step, 10 plus 40 minus 1 is 39 into 10. So next step, 10 plus 39 tens are 390. So the answer is 400. So 400 will be the 11th term from right to left, from 500 to the, therefore 400 will be the answer, the 11th term from the last to first of this arithmetic progression. How we found this answer? Okay, I shall repeat again. We got a sequence 10, 20, 30, etc. The progression terminates at 500 and we want to find the 11th term from last to first. So we found the position number of 500, the last term. The 500 will be in this sequence. It is very easy because these are multiples of 10. So we can simply write here the 500 is the A50. The 50th term will be 500. So there are only 50 terms. So out of 50 terms, the 11th term from right to left will be the 40th term from left to right. Right? So now the question reduced to find the A40 of this arithmetic progression. And we know how to find 40th term of any arithmetic progression if we know the first term and common difference. So we found the 40th term using the nth term formula. And we got 400. Okay. There's another method. We can do the same. The second method is little more simple. So to find the 11th term from last to first of this arithmetic progression, firstly we can write this arithmetic progression in reverse order. Okay, we know 10 is the common difference for this arithmetic progression. We add 10 to get the next term. So when we write the sequence in reverse order, we want to start from 500 and what will be the next term? Next term will be 490, then will be 480, and the sequence will terminate at 10. Okay, now our question is to find the 11th term of this arithmetic progression, this reversed arithmetic progression. And in this arithmetic progression, A is equal to 500 and D will be, what will be the common difference? Okay, when we reverse an arithmetic progression, the common difference will become negative of the original arithmetic progression. So here our given arithmetic progression is 10, 20, 30 and its common difference is 10. Therefore, when we reverse this arithmetic progression, our common difference will become minus 10, right? So 500 plus minus 10 is 490, right? 490 plus minus 10 is 480, etc. Okay, so we only need to find A11. So A11 is equal to A plus 11 minus 1D. Here A is 500. So 500 plus 11 minus 1 times D. D is minus 10. Okay, into minus 10. Okay, in next step we can write 500 plus 11 minus 1 is 10. So 10 into minus 10. Okay, so what is 10 into minus 10? So 10 into minus 10 we know minus 100. So 500 minus 100 will be the answer. So we'll get to the same answer, 400. So there are two methods to solve this question. So in the first method, we didn't reverse the sequence, but we found the position value of the last term, 500, that is 50. From that we understand that out of 50 terms, the 11th term from right to left will be the 40th term from the left to right. So we calculated for A40 of this original arithmetic progression. And in the second method, we made the arithmetic progression in reverse order. So what happened? The last term of the original arithmetic progression became the first term and common difference became the negative of the original arithmetic progression. Okay. Now it is enough to find the 11th term of this reversed arithmetic progression. That will be the 11th term from last to first of the original arithmetic progression. So we know the nth term formula. Using the nth term formula, we calculated A11 and we got 400. I hope you understood. Okay.